This is our preliminary winter forecast for 2026 to 2027, and it is by far the most anticipated video we put out every single year. We're going to walk through the temperature forecast, the precipitation forecast, the snowfall forecast, and the overall regional breakdown, and we're coming off 2 winters in a row where our forecasts hit with real accuracy. So the bar going into this one is high, and I fully intend on making it 3 in a row. Let's start with temperature, because that's the foundation everything else builds from. We're layering this forecast in tiers of confidence, not raw intensity, meaning the more layers stacked over a region, the more confident we are in the direction of that anomaly, whether that T is below normal or above normal, rather than how extreme that anomaly will end up being on any single day. The first layer of below normal temperatures covers the southwest, the south central states, the southeast, the Ohio Valley, and stretches into the northeast and mid-Atlantic, where we lean below normal for the season as a whole. Now, the elephant in the room. We're heading into a record-breaking super El Nino for this upcoming winter, and that's going to be the dominant driver behind nearly everything in this forecast. Because El Nino of this strength has an outsized influence on the position and strength of both the north. Earn and southern jet streams, and those jet streams are what ultimately decide where the storms track and where the cold air ends up parking itself. A super El Nino means unusually warm sea surface temperatures across a large stretch of the equatorial Pacific. And that warm what? Air fundamentally reshapes where thunderstorm activity and rising air concentrate near the equator, which in turn shifts the position of the jet streams thousands of miles away at the surface. That's the whole reason AW, arm water anomaly sitting out in the tropical Pacific, can end up determining whether Boston gets buried in snow or Seattle stays unusually mild for months at a time. With a super El Nino on the table, there's also going to be more room for surprises than a typical winter, and that's worth keeping in mind as the season plays out. We have a second layer of below normal temperatures, covering essentially the same footprint as the first layer, just with higher confidence attached to it. That's where the forecast starts to sharpen. And then things get genuinely interesting. We add a third layer because we move into moderate to high confidence for the deep south, the southeast, and the lower mid-Atlantic, all being below normal for the season. Some of that cold is going to come straight out of the Arctic, and we expect that Arctic cold to be fairly east-based this year rather than spilling as far west, as it sometimes does, for reasons tied directly to the jet stream pattern we'll get into shortly. But Arctic intrusions aren't the only mechanism at play here. We're also expecting a very active southern jet stream to drive a steady parade of storms across the southern states and up the east coast, and that opens the door to something meteorologists call dynamic cooling, where heavy precipitation physically drags colder air down from the upper atmosphere to the surface as the storm moves through. With a southern storm track running this active, we expect dynamic cooling to be a bigger factor than usual this winter, adding to the below normal temperature signal across the south independent of whatever the Arctic is doing on any given week. On the flip side, the above normal temperature forecast covers a large chunk of the northwest and north central states, including the upper Midwest, and this is where the northern jet stream comes into play. We expect that northern jet to run very strong this year, though noticeably drier than the southern branch, and what it's going to do is pull mild Pacific air onshore quickly and consistently into areas that typically deal with harsh Arctic conditions throughout the winter. Instead of the usual Arctic outbreaks, a lot of these areas are going to be dealing with something closer to North Pacific conditions for large stretches of the season. That signal is strong enough that we've stacked a second layer of confidence on top of it for the Pacific end, Northwest, the Northern Rockies, and the Northern Plains, and then a third layer joins almost immediately after that. We're not stopping there either. A fourth layer gets activated across that same footprint, and we've gone all the way to a fifth and maximum layer of confidence for the Northern Plains specifically. That's about as confident as this kind of layered forecast gets, and it lines up with what we typically see during a stronger El Nino winter, where this exact region tends to run warmer than normal almost every time. It's worth being clear that the cooler temperatures forecast for the southwest aren't primarily an Arctic air story. That region's below normal temperature signal is driven mostly by that same dynamic cooling mechanism, tied to increased cloudiness and more frequent precipitates, ion moving through, rather than cold air masses dropping down from Canada. We also anticipate a fairly dominant ridge setting up over the west this winter, essentially a continuation of the pattern we saw over the past 2 winters, and honestly, a pattern that's carried through SP, ring, summer, and now looks to extend right into this fall and winter as well. Meteorologists refer to this kind of setup as a positive PNA pattern, short for the Pacific North American pattern, which describes a recurring configuration of ridges and troughs stretching from the North Pacific across the continent. And when the PSI oscillative phase is in place, it typically means a persistent ridge of high pressure sitting over the western United States and a corresponding trough further east. When it's in place, It tends to push colder air around the west rather than through it, following the path of least resistance along that strong Pacific jet. More often than not, when that cold air does eventually make its way east, it comes in as what's called BI, skikt or cold air, arriving from the northeast rather than dropping straight down from the north, sliding in behind a departing storm system along the backside of high pressure centered over eastern Canada or the North Atlantic. And that's a pattern we've seen show up with real consistency in recent winters. So recent history is playing a meaningful role in this call. Moving into precipitation, this is the piece of the forecast most directly controlled by the super El Niño, since El Niño's influence on the jet streams is really what determines where the storm tracks set up for the entire season. Historical analogs for winters, this strongly influenced by El Niño, show a handful of regions running very far above normal on precipitation, and we'll get to those, but let's start with where we expect below average precipitation. That northern jet stream we talked about, the one delivering mild Pacific air into the northwest and northern plains, isn't a particularly active storm track. It's a drier jet overall, and one of the clearest signals in ESTR. Ong El Niño winter is a notable lack of the Clipper storm track, the fast-moving, moisture-starved systems that dropped out of Canada frequently in each of the past 2 winters, especially last winter. In a super El Niño year, like this one, we simply don't expect to see nearly as many of those clippers, and that absence translates directly into drier than normal conditions across the northwest and north central states. We're carrying moderate confidence on that drier signal, and it strengthens into moderate to high confidence for the northern plains, upper Midwest, and northern Rockies specifically, again largely because of that missing clipper track that shows up so frequently in other winters. On the above average precipitation side, the pattern lines up closely with where we're forecasting below normal temperatures, which makes sense given how tightly dynamic cooling ties precipitation and temperature together in those regions. We're expecting above average precipitation across the southwest and south center, RAL states. We anticipate a good amount of Arctic air working its way down the east coast as well, paired with a very active nor'easter storm track. Expect a stormy deep south and a stormy east coast overall this winter, with plenty of setups capable of producing major snowstorms in the right areas. We're carrying a second layer of above normal precipitation confidence across the southwest, south central states, and east coast. And from there we move fairly quickly into higher confidence layers. We have moderate to high confidence for the southwest, and separately moderate to high confidence for the deep south all the way through the entire east. Coast, driven by that frequent nor'easter track. The southwest specifically tends to get a very active southern jet, delivering repeated onshore storm systems during El Niño winters. And more often than not, those years land solidly above normal on precipitation there, which is why our confidence in that region runs high. We've even activated a 4th layer for the south, a stern coastline, since even when nor'easters track a bit further offshore, they still tend to deliver meaningful precipitation to those coastal areas. And for the southwest, we've gone all the way to a 4th layer as well, reflecting just how consistently active we expect that storm corridor to be. We've actually pushed all the way to a 5th layer of confidence specifically for California and into the southern 4 corner states, which is about as strong a signal as this forecast produces anywhere on the map. Now for the snowfall forecast, and it's worth clarifying up front that what we're showing is a snowfall chance forecast rather than a straight snowfall total anomaly. Snowfall is genuinely difficult to forecast this far in advance because you can have cold air in place but arriving dry, head by a wetter system that arrives on the warmer side, and the cold can end up dodging the moisture entirely in ways that are essentially impossible to predict at this range. That's why we favor snowfall chance over hard snowfall totals for a forecast released this far ahead of the season, since it captures which areas have a better or worse chance of hitting typical snowfall levels without pretending we can nail down the exact timing of any individual storm. Starting with below average snowfall chance, this lines up closely with the areas we expect to run drier and warmer overall, which isn't a surprising overlap. The Northwest, Northern Plains, and Upper Midwest carry that below average snowfall chance signy. And we've got a moderate layer of confidence stacked on that same footprint, reflecting where we expect the warmest and driest conditions of the winter to show up most consistently. That part of the forecast is fairly straightforward once you understand the temperature and precipitation pattern underneath it. The above average snowfall chance areas track closely with where we're calling for above normal precipitation and below normal temperatures, since colder air, combined with more frequent storm systems, naturally raises the odds of snow over rain when a system does move through, even though we can't predict the exact timing that determines which side of that line any individual storm falls on. We've got a first layer of above average snowfall chance across the southwest, south central states, and east coast, and a second layer specifically pinpointing California, Nevada, and the Four Corner states. Now, Some of you might be wondering why areas like Southern California show up on a map calling for above normal snowfall chance, since large parts of that region obviously don't see snow, especially away from higher elevation terrain. The answer is that this is strictly a chance forecast. If the baseline odds of snowfall somewhere are, say, 1 in 10,000, an above average chance might move that to something like 1 in 900. That's still overwhelmingly unlikely on any given day. It just means the odds have shifted upward relative to a typical winter. Not that snow is actually expected in those low elevation areas. But for the Sierra Nevada, and the Southern Rockies, this same signal translates into a potentially massive snowfall winter, and we don't stop building layers there either. We've got a third layer of above average snowfall chance for the Southwest, and a fourth layer covering California, the Sierra Nevada, and further into the broader Southwest region. For the Sierra Nevada specifically, we've pushed all the way to a fifth layer of confidence, and that kind of signal shows up in roughly 9 out of 10 moderate to strong El Nino winters. So we don't see any strong reason to expect this year to be the exception. The East Coast builds its own set of layers as well. We've got a second layer of above average snowfall chance for the Gulf states and East Coast, tied directly to that frequent nor'easter track, and the recurring pockets of Arctic air we expect to move through the region, and that combination is exactly the recipe that produces meaningful snowstorms. A third layer follows across the deep south, southeast, and up the entire eastern seaboard, just like with S. Now let's move into the region-by-region overall outlook, which always ends up being the most detailed part of the video. Starting in the northwest, we're expecting a drier and warmer winter overall, essentially the mirror image of what these are, as typically seen during a La Nina winter. And worth noting that we're coming off back-to-back La Nina winters heading into this one, so this represents a genuinely significant pattern shift for the west. The southwest, by contrast, looks very stormy and cooler, with a highly active storm track expected to move through repeatedly across the season. The Rockies are a genuinely tricky region to summarize in a single line, because the pattern really splits north to south. The northern half of the Rockies likely trends below normal on snowfall this winter, while the southern half, especially Colorado, Arizona, and New Mexico, could end up extremely active, with some of these mountain ranges seeing a standout snowfall season. Moving eastward from there, areas just east of the Rockies in Colorado, and parts of the adjoining plains could see a fairly snowy stretch as well, as systems track through that corridor repeatedly across the winter. The north-central states carry a bit of a question mark tied to the polar vortex. Even though we're forecasting above normal temperatures overall for this region, the Arctic has been running in a genuinely unusual state over the past couple of dallywag enters, consistently overperforming relative to typical expectations, and we don't see strong evidence that's about to change heading into this winter. We do think polar vortex disruptions are still on the table this season, potentially briefer as they track eastward, but capable of reaching even into these more western areas like the northern plains and parts of Montana and Wyoming at times. That said, the overwhelming majority of the winter in this region should run milder than normal. Nebraska, Kansas, Iowa, and Missouri should see a generally milder pattern too, with somewhat reduced precipitation and temperatures running a touch above normal across the season as a whole. The deeper south is what we like to call the winter battle zone, and it always deserves a bit of extra explanation. Across that broader region, we expect frequent battles between rain, snow, and ice within the same storm systems, which is a recurring theme for this part of the country, and this winter won't be an exception. That battle zone label comes from the fact that this region typically sits right along the boundary between warm, moisture-laden air streaming up from the Gulf of Mexico and cold air pushing down from the north, and depending on exactly where that boundary ice sets up on any given storm day, the same system can produce heavy rain in one county, a damaging ice storm one county over, and measurable snowfall just a bit further north, all within the same weather event. Messy, mixed precipitation storms, particularly ones bringing ice and sleet, can actually end up more dangerous than a lean snowstorm, since ice accumulation causes its own distinct set of hazards on roads and power infrastructure, coating power lines and tree limbs in a way that can trigger widespread outages even from a relatively modest amount of total precipitation. We're expecting major storm systems across the deep south, stretching all the way into Florida and Georgia, and back west into New Mexico and Texas, along with above-average, severe weather activity through the winter season, which is a fairly common feature of El Nino winters in this region, since that same active southern jet responsible for the wet pattern also tends to support stronger storm dynamics, capable of producing severe thunderstorms even in the cooler months. These areas should see frequent storm systems here all, and we can't rule out occasional deeper Arctic intrusions reaching into the deep south either. With the above-average precipitation signal we're carrying for this region, there's a real chance of seeing one of those rare snow events that occasionally reach into the deeper south, though we'll have to see exactly how the season plays out before saying more than that. For the Midwest, Ohio Valley, and parts of the Great Lakes, we expect Arctic blasts to show up fairly frequently this winter. At the same time, that milder Pacific air we discussed earlier will periodically reach this far east as well, so this region should experience a genuine back and forth pattern across the season rather than settling into one consistent temperature regime, swinging between stretches of unusually mild weather and sharp cold shots depending on which side of that jet stream battle happens to be winning in any given week. Lake effect snow could be a significant factor again this year, and it's worth noting that lake temperatures are running quite warm heading into this winter. The mechanism behind lake effect snow depends heavily on the temperature difference between the lake surface and the air passing over it, since cold air moving across relatively warm open water picks up moisture and heat, then dumps that moisture as intense narrow bands of snowfall once it reaches the colder shoreline. If colder air arrives over those unusually warm lakes, especially earlier in the season during November and December before the lakes have had a chance to cool down and begin freezing over, that combination can produce some substantial lake effect snowfall totals for communities downwind of the Great Lakes, potentially delivering some of the more impressive single event snowfall totals of the entire winter in the traditional lake effect belt. Moving further east, we anticipate the potential for some genuinely large snowstorms across the Appalachian mountain range and the broader interior eastern region. That area saw several significant snow events last winter, and with the nor'easter storm track we're forecasting for this season, we think this region has a real chance to consistently cash in on some sizable snow systems throughout the winter. Finally, for the mid-Atlantic and northeast, the biggest factor driving this year's forecast is going to be those frequent nor'easters. We expect several of these systems to reach strong nor'easter intensity, and whether any individual storm arrives primarily as a snow event or more of a wind and rain event, the overall impact across the Aegean should be significant either way. We think coastal areas along the eastern seaboard are looking at multiple opportunities for major snowstorms this winter, based on the combination of our temperature forecast and the active nor'easter track we expect to see develop repeatedly through the season. That covers the full breakdown for winter, 2026 to 2027. This continues to be one of our favorite forecasts to put together every year, and we're genuinely proud of the track record built over the past 2 winters heading into this one. As always, expect updates as we move deeper into fall and get more long-range model guidance to work with, since these preliminary outlooks typically get refined at least a couple of times before the season fully arrives. We'll keep tracking the Super El Niño signal closely as autumn progresses, along with how that positive P&A pattern and the state of the polar vortex continue to evolve, since those 3 factors together are going to do most of the heavy lifting in determining exactly how this winter plays out on the ground. If you want a more specific read on how this pattern is likely to play out where you live, drop your location in the comments, and we'll be working through those to give out some more tailored notes as the season gets closer, especially once we get more model runs in over the coming weeks that let us narrow down the regional details further. We upload new content on this almost every single day through the fall and winter, including regular long-range model updates as new data comes in, so if you found this breakdown useful, subscribing is the best way to catch ever. I update as the picture sharpens. We'll be back with a refreshed version of this forecast as we get closer to the season, incorporating whatever new signals show up in the meantime, so keep an eye out for that follow-up as we move through the rest of autumn.